All right, everybody, welcome back to class. This week we are going to be talking about regular expressions, or regex for short. And as usual, the Python code is here in the content folder. Just copy and paste it into your VS Code so you can follow along. And along with that, this week we have a quiz, which I have not yet written, a discussion question, and then a quick assignment as usual. Okay. So I've already copied out the content and I've got it here in my VS Code. So I'm ready to go. Okay, so regular expressions deal pretty much exclusively with strings. And we haven't done a whole lot of operations with strings yet. So we're going to add another tool to our toolbox here. So with strings in the past, what we've done typically is, we'll set some variable equal to a string, and that can come in a lot of ways, right? It could be like I've done here, or it could be what we learned last week, which was how to read strings out of a file. But even in that case, we're still setting a string to a variable, right? Just larger and more complicated strings. But here's an example here, right? So all we've done is we've assigned strings, we put them into variables, and then once we've had them in strings, we can do a few things we've talked about, but the most common thing we've done so far is we'll just do some sort of checking, right? We'll say, is this string equal to that string? If so, do something. Or we get a little bit fancier and we try to make sure the cases are the same so that they'll still match, right? These ones are capital H, capital I, capital V. This one has a mixed case here with capital H and lowercase I and V. So we just force them down to be the same case, right? And we're just checking to see if they match. So it's a little bit, basically what we've done with the string so far. There's a lot of more things you can do with strings in Python besides regex. This is typically what we've done so far. Okay, so these things are just checking the entire string, right? Is this whole string equal to this whole string? And from doing the assignments past that there's other things you can do. For example, take this string here. This is diagnoses, and this is a comma-separated list, just like we have done with the last assignment reading files, right? So when we have a larger list and we want to find a subset or a small little portion of that string, we have a few different options, right? So we have this first one here on line 24, right here. We can just say, take this list of diagnoses, this one right here. We can convert it all to some specific case, either upper or lower, doesn't matter. We're just trying to make sure they're all apples to apples. And then we're just saying, is this string inside of that string? And that works just like we've done with lists and arrays and sets and dictionaries and all that stuff before. You can just say, is this item in this larger list or collection of items? And if you don't remember, a string is actually a list. It's a list of characters. So we can do this in operator on it. Right there. So we're just saying, is HIV in this string? And it is right there. It's the very first item. Okay. Let me just run this code so we can keep up with it. Okay, so just back up here, diagnosis, that's a match. Throw them all to lower, that's also a match, we found it. And now here's where we were. We convert all these diagnoses to uppercase, look for HIV, and sure enough, it is right there. Okay. And then what we learned the other week with reading files, since this is a comma-separated list, we have another way we could do it. So this is the easier way, right? This is just is that in that. Another way we can do it is we can do the split, which is again what we learned with the CSV data. And so this gives us this list of these 5 items. And then we're just trying to look at each of these one at a time, saying, is this diagnosis uppercase in there? And it is. It's the first thing, right? This isn't very great written code because it keeps on searching. Once it found its match, it should have stopped. And we can use the break command that would have stopped this, but it kept going through all of them. So those are the things we've talked about with strings thus far. I don't think we've talked about these, but this is similar to what we've been trying to do up here. It's similar to the in clause right here on line 24. We can do, there's these other things we can do with strings called index or find. And if you want to see the details about them, you can do this with your parentheses, and your little documentation comes up about it. It tells you what parameters it takes and what it does. But both of these do very similar things. They're slightly different, but not different enough that I'm going to talk about them in this class. I'm putting them here together just to show you they're basically the same thing for what we're concerned with. And so you give it a string, which is our diagnoses. You're going to go find the index of, or just go find the string, and you pass it the string you're interested in. There's a bunch of other arguments you could pass in there optionally, but we're not going to talk about it. And all it's going to do is return you the index. And by index, it means the number, the position of the character in the string. So it could be anywhere from 0 to however long your string is, 0 being the first character, and then whatever your other number or character is. And so all it's going to do is return that number if it's there. And if there isn't, if there is no matches, it returns a -1. Or actually, it says it's going to raise an exception, raise an error here. Other programming languages I've used, they just return a -1. Python throws an error. Okay, so we said go look at this whole list of diagnoses, convert them all to uppercase, and find me the spot where HIV starts. And it says 0. And that's what we would expect, right? We look at the diagnoses, it starts here at the first character. That's what it's telling you is where it starts. So it starts at spot 0. So it found it. That works. And then likewise with the find, we do the exact same thing, but with the find, and it also returns us a 0. So it's able to find them. And we're just going to go check and see. As long as we have some positive number, then we know it's in there. So that's another thing that I don't think we've talked about before, but you can use that to go find strings. Okay. There we go. So these things will probably work pretty okay for us, for the most part. They're going to do a lot of the stuff that we need. But when we're trying to do some data extraction on some complicated data, not even complicated data, when we're trying to do data extraction, we're not necessarily always going to know exactly what we're looking for, right? We knew HIV, but it could have been H period, I period, V period. It could have been human immunovirus. It could have a few different forms. And so we would have to code all of those separately, which is fine. But there are times when we can see patterns of things coming up. So imagine our CSV data that we had before, right here. So here's some examples. These are, again, just fake data, but the idea is we have a patient ID, comma, the patient name, comma, the age, the gender. I assume this would be their insurance company, and then maybe their allergies, right? Just some very basic nonsense information, and then each row is specific to the patient. So there's data in here, and we can start to see that there's some patterns here, right? In the past, or in the last lecture, we talked about reading each line of a file and then splitting on the comma. That gives us an array. Now we have all the data, in its own little bin and a list, and then we can go start doing comparisons. Is this equal to that? And that's fine. But what if we wanted to do something a little bit more fuzzy, right? We just want to go grab the age of the patients. How would we grab the age of the patients using this sort of data, right? We got this 39-year-old, the 16-year-old, and the 13-year-old. We want to grab that. So how would we do that with the tools that we have in our toolbox right now? Well, just like I said, we would go grab this list of strings. We would split them on the new line. So that means each row is going to get its own line. And then for each patient, we're going to do split on the comma. And then we're going to go look at the third item in there, right? So 0, 1, 2. And that would work. That would give us the 39-year-old. Let's look at that just to prove that this would probably work. I don't think I've actually tested my code. I just wrote it quickly, but it should work. oops, you can see right here. Yep, so it's parsing it out, and it will be looking for the second one. And I'm printing them out here to the screen. So we did get the 39, the 16, and the 13-year-old. Right, so that's what we know so far. And so that's how we could get the age for the patient out of there. It's kind of sensitive code, meaning if the order of the data ever changed, for example, if the 39-year-old, or sorry, the age of the patient was moved a spot, this wouldn't work. This would start to break on us, right? If whoever senses this data decided one day to change where the age was and put it here in the last spot, this code would stop working, right? That's what I'm talking about right here. We can be a little bit more generic so we just talked about the index up here, the index and the find. So I wrote another example here on how we could be a little bit more generic. It's a little bit more complicated of a code. But I'm trying to look for just a pattern here, or not worry about what spot this is in. We know that this is the third spot, the age. But if we just wanted to ignore that and just look in all of the data and just try to find a general pattern, here's something we could do, right? So I'm going to create an infinite loop. This is just going to allow me to read all the data. I'm going to go to that patient's data right here. I'm going to go do the index like we saw just above, looking for the yo. That means years old, right? So in this data, we're assuming that years old is always there. That seems to be a constant, at least in these 3 rows. We'd have to have more data to know if that holds true or not. We're just going to assume for this case that it is. And so here's one of the extra arguments you can pass to index, which is where you want to start at. In our case, we're starting here at 0. He's going to go say, oh, yeah, I found years old at line or spot 22, right? So spot 22 in patients is right here, between the 9 and the Y. It stops right there. It says, oh yeah, I found years old right there. And then we're going to go say, okay, go to that data, go to the spot 22, back up 2 spots, and then also go forward to where you found the years old. So we're just going to go slice it. This is called slicing a string. And then here's what it returns. It's just 39, which is great, right? We're making some assumptions here, right? We're assuming that these are only 2 ages. We could have a 100-year-old, or we could have a 8-year-old, which is a single digit. So we kind of break there. We need more sophisticated logic for that. But we successfully went and found the age of a patient without splitting it on the comma, and without really caring what spot it was in there, right? So we're a little bit more robust here, a little bit more error proof. We don't care if they change stuff on us now. As long as there's the YO, the years old, we can successfully find the age. We just saw that, right? So we'll do it again. Let's go see if this happens again. So now we take where we left off. We left off at line, or at character 22. We advance it just 1, right? Because we don't want to keep matching on the same thing over and over. So now we're going to say, all right, go to spot 23 and start your search again. I said, oh yeah, I found years old at spot 77. So now if we go hover and look over this, spot 77 is right here between the 6 and the YO. And as long as it found a match, again, it's going to go look backwards 2 spots. And now we've got the age of 16. And we print it out, right? So now we've got the 39 and the 16, right? So we're doing pretty good with this. It's a little bit more complicated. And so we got the 13. We threw an exception. So we've wrapped this in the try except, because we saw here that the index method will throw an exception if it finds no matches. So it found no matches because we've already got all 3. We've got the 39, the 16, and the 13, as you can see there. We found no matches. So I'm just manually setting it to a -1. And then I'm saying if it's a negative number, we're just going to exit out of this, which we did. And so we were able to successfully find that, right? So that works. It's a little bit more complicated, but it works. So what we're going to talk about today is maybe a little bit of a better way to do this, right? So these probably seem a little bit complicated. I don't know. They're very ascertainable, right? We can work with this. We can make this happen. We can understand this if we work with it a little bit. But there is a different way, and that's what we're going to be talking about this week, right? So we just set the stage for how we could do things. Now we're going to talk about maybe a better way. And these are called regex, or regular expressions. And all these regexes will let us do is look for patterns. So it's a little bit different way of thinking, right? We kind of started to make a pattern here with this YO, right? We looked at the data. We're like, oh yeah, we can kind of tell this is going to be roughly in the third spot. Or we also saw that it's roughly going to have a YO on the end, right? So we ourselves were looking for patterns when we did it. So now with regex, we can just try to codify that pattern and look for certain things in here. Okay. Okay. So to use regex, we got a few things. First, we have to import the library that Python's written for us. This is the easiest one. I'm sure there's other libraries out there you could go grab, but this is the standard Python one. It's called RE, regular expressions. So we got to go import that to use these functions. This is the exact same data I had above. I just pulled it down here for us to read easier without having to scroll all the way up. Okay, so this is all the same data. Okay, and so here we got to start thinking about, so say we want to grab the age, just like we did up here, right? We grabbed the age this way, and we also grabbed the age this way, right? We found it in the third spot, or we found it with the YO. We found it two different ways, but we need to start thinking about what's the pattern that we're after here. So it's going to be a different way of thinking. So this is sort of the pattern, right? We saw that there's a comma. We saw that there's some sort of number, right, like the age. And then we saw that there's the years old, and then there's another comma. Right, so if we could find this, we'd be doing okay. And we don't really know what this age is. And this is where the fuzziness comes in. I talked up here a little bit about a fuzzy logic right here. We don't really know all the details. We just have a general idea that it's going to be this. We don't know what the age is going to be, right? It could be 1, could be 100. Okay. So what we want to do is how do we convert this general pattern that we're looking for into a regex pattern? And so regex has a handful, not a handful, I have probably a couple of dozen specific little characters that they use that we can put together in whatever order we need them to be put in to try to represent this pattern. And these probably won't make sense just looking at them and reading them. I put them here for you so you have a quick little handy guide, but you'd probably be better off just going to Google and just typing it in. There we go, something like this. Here's a quick cheat sheet. You can go find whatever makes sense to you, right? So here's the 12 most common ones. There's a lot more than just 12. But my point is, what I've written here in VS Code is not going to be, A, it's not complete. I only got the most common ones. I didn't bring in all of them. And B, the descriptions I have may not be the best descriptions. So go look what makes sense for you. And there's also things like this where you can see how things get put together. That's probably a little bit more complicated to see right now than you want, but we'll go start building our own pattern. And this is showing you how things are getting broken up. Here's another one. Right, there's a whole bunch of stuff out here. So the point is, regular expressions are not Python specific. Every language I've ever written has regular expressions, and they all use the same characters, right? So this is not Python specific, but it is very helpful for us to use in Python when we start to pull in data from files and other things to start parsing and breaking things out. Okay, so some of the more common ones people would use are like the /d just means only match on digits, meaning 0 through 9, or /s is what are all the white space, find me all the white space characters, you know, like the new line, the space, the tab, things like that. Those are called white space, meaning things that take up space in your line, but things that you don't actually see or read. And then the /W is all the letters and numbers, so A through Z and 0 through 9. And then these talk about how many you're looking for. So like the dots, and then you have like the pluses right here. This is saying find one or more. This is finding 0 or more, finding 0 or 1. And then we have the exclamation, which means not, which means to find the opposite of that or don't find that. And then in the curly braces is the next most common thing. We're saying go find a specific number of those things. So whatever number we put here, instead of the M, we could say 3. Go find this pattern that happens 3 times, for example, or a range happens between 1 to 3 times. So there's all of these special things that you can put together to form a pattern. And so that's what we're going to do here for the rest of the class is we're going to try to build a couple of patterns just to show you how regex works. And we're going to start out simple. We're going to get a little bit more complicated intermediate stuff, but we're never going to get advanced because it gets pretty crazy pretty quickly. And again, it's just a real different way of thinking about it. Okay, so let's take our example that we want to do right here. Right, we're still on this pattern. We're trying to find the patient's age. We have all that data. We want to write a pattern that'll help us go find that age. So we're going to go look and start building our pattern. We're going to do it slowly. We're going to build it up a little bit at a time. Okay. So let's take this part right here, just the age. Just the age. So we know we're looking for a number. Okay. We don't know how many numbers we're looking for. We just know they're numbers. So we have 2 options we can do based off this list up here I gave you, or if you want to go Google it, we have 2 options from there. The /D just lets us find any digit, or within the square brackets right here, we're telling it a set of characters that we're interested in matching on, or a range of characters like this, right? We could type A to Z, which is all the letters, or I typed 0 through 9. So it's going to go find all the numbers between 0 and 9. Okay. So with our regex, we imported the library, right? The RE library right here on line 100. That's RE. So we go do RE dot, I'm using find all, but look, there's other options here. The purple ones are what we're looking for. So there's find all right there. Find the iterator, find the full match. That's basically it. Or match. Match the next most common one. Match just is going to return you some sort of Boolean. Is it there or not? I prefer the find all because it's going to give me all the instances of something. Okay, so we go to find all method, and into it we pass, right here, we pass it in the pattern we're looking for, and then the string we're going to search. And there's other optional things we can do. And then it says it's going to return us a list of all the non-overlapping matches in a string. And that's it. Okay, so we said here's our pattern. Square brackets means a range of numbers. And then here's the string we're searching. So now if we run it, we ran it really quickly. We hover over the result of it. Here's everything it found. A lot. It found 27 items, and all it did is what we told it. It went and found all the numbers between 0 and 9. So not super helpful yet, but we can see that it's very successful at finding numbers 0 through 9 and returning them to us in results. So we got to make our pattern a little bit smarter. Okay. Yep. So it just found all the digits. But we need to make a better pattern. So we need to make sure that there's between 1 and 3, okay, right? Because the age of a person can be 1 number, 2 numbers, or 3 numbers. Not 4 yet, someday. And to do that, we have the curly braces up here, right here, line 122. So we're just saying that they need to match between M and N number of times, so between 1 and 3 times. Okay. So now we take the same code that we had. Here's that pattern of square brackets saying here's the range of numbers. And now we're getting a little bit smarter and we're saying now find it between 1 and 3 times. And so the key here of what we're seeing, or what this does for us, is on the find all, you remember it said it's going to find non-overlapping pairs. That's the part that's really helpful for us. Because when we add on this extra qualifier, this curly braces 1 to 3, that's called a greedy operation. And greedy operations are really good and really helpful for us because what it means is it's going to start at the highest number possible. It's going to go say, all right, where's all of the threes? How many, all the numbers that are in a group of three, and it's going to find those first. Then it's going to go find all the matches of twos, find those first. And that's going to go find all the ones left over and match on those. But what helps us here is that the find all does non-overlapping. So if it found a group of three, once it starts to move to the group of two, it won't do any matches that overlap with that group of three. It has to be a distinct group. And so that's really helpful because otherwise we'd be getting all those same results that we saw before, right? All the single numbers, and that's not very helpful. We want it to be as in big a groups as possible. So now we run that same thing with this greedy 1 through 3. And now you can see when we hover over it, a lot less results, right? We had like 27 before, now we're up down to 12. And we got as big a groups as possible, right? We have a whole bunch of these threes, we have some twos, and we have some single numbers left over. And if we look up here at our data set, these numbers are coming from here, right? Like a patient identifier, it's gonna go find 3 of those. And that's basically it. And then these zeros, it looks like it's grabbed a few of those zeros on their own. What else? Yeah. And we know the patient's ages are 39. So it found the 39 on this 4th item here. It found us our 16 on number 7, and it found us our 13 on the last one. So we see that it's finding them. We just need to get rid of all this other noise. Okay. So we have to be more specific. We got to make our pattern even better. Okay. So we know that all of our ages are by a yo, right? We know they're right before the yo. So that's all we're going to do is we're going to add that here at the end. So we've still got our square brackets, which is a range of numbers, 0 through 9. Our curly braces are saying it has to occur at least 1 to 3 times. And now we're saying it also has to, that whole pattern has to be right before a yo, a yo. Okay. Now when we look at our results, we have this, which is really great. We have just the ages of the patients. So we have the 39, the 16, and the 13. We do have the YOs on the end, so we'd have to do a little bit more processing if we wanted to do math on it, calculations on it. We'd have to go strip off the YO, convert it to an integer, because these are strings, you can see with the little ticks there. But we could do a little bit cleanup on our own. The point is we were able to go into that data and find just what we needed. And we did it all at once, right? So this one line of code went and found us all the patient ages. There's only 3 in this case because that's all our data is, but we had, like tens of thousands or whatever. It would have found all 10,000 of them for us immediately. That's pretty quick. That's pretty clever, right? So you just need to start thinking a little bit more regexy. And you can go grab the data really quick because the alternative without using regex is what we had up here, right? We could go do these loops or we can go do these splitting things or whatever we need to do. But this is a whole lot quicker and faster and probably more efficient, definitely more efficient. There we go. Okay. So now let's try to change up our pattern. Let's look for something else. So we found the ages all right. And so again, I put this data back here. Now let's do a little bit something more abstract. The ages were easy, right? Or easiest, I think. That's why I started with them, because it's a number right before the yo. How are we going to go find something like, let's find patient names, right? That's just a bunch of characters. How the heck are we going to go get that? And how are we going to differentiate patient name from something like your allergy, right? Which is amoxicillin or something. How are we going to differentiate those things? Okay. So let's try to break it down and think about it. What our pattern could look like and what our choices are we have to work with it. So we know that we have a bunch of characters. So looking right here, we know we have a bunch of characters. We have a space, and then we have a bunch more characters. So that's our general sort of thing we're looking for. So we can codify that. We can do the range function, just like we had above with the numbers. So we put in square brackets. We can say we're looking for all the lowercase letters A through Z, or all the uppercase letters A through Z. So this is just saying we don't care what case it's in, but it can only be a letter, A through Z. And then the other thing we can do is the \s comes to us from up here on line 127. That's just all the white space characters. Okay. Like a space, or it could be other things, but we're just going to hope it's matching on a space this time. We're just kind of coming up with our first stab at this pattern, and then we're going to run it and see what results we get, and then we're going to fine tune it. Okay. So this is what we did. We said, here's all our characters. Here's the white space, and then here's more characters. You'll notice that the S, we just had it as a \s up here, because that's what regex is looking for, is a \s. But Python, our programming language, doesn't like having a single backslash. If I get rid of it, well, I'm not going to save it yet. It would go red. I would have to stop the program to do it. Let's do it. Okay, so if I stop the program and save it, there we go. You can see that we got this issue right here on X, and it says, it's like you can't do this basically. And so the backslash is really throwing it off. And so we have to put 2 backslashes. The first backslash is telling Python to ignore the next backslash, basically. So we have to put 2 of them in a row for Python's sake. But that's it. So let me put a breakpoint there, start it up again. Get rid of that. Okay, so here's our name pattern. Let's see how well we did. Hover over X. Yeah, it did pretty much exactly what we wanted. We found a character, A through Z. We found a space, and we found another character, A through Z. And casing doesn't matter, right? You can see we have lowercase and uppercase. That's really exactly what we told it to do. So good for us, I guess. We just need to get a little bit smarter about it. I'm trying to think. We can look at, because we only have 3 patients, right? But we're getting 6 results. So what it's matching on is the select health. It's the same pattern. Select med is the same pattern, and another select health is the same pattern, right? So this is like the select health, select med, select health. Okay. So it did what we told it to. That's a start. That's good. We need to make it a little bit better. We need to add another greedy operator onto it. I like using the word greedy. That's what they're called too. They are greedy operators. So we're going to take the exact same pattern that we've done, right? This is exact same, but the only difference is I'm adding these plus signs. So I'm adding the plus signs to the left for all these letters before the space. And then I'm adding this plus sign at the end of that for all the letters on the right of it, of the space. And if we look at what the plus sign does, where is it? Plus, 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 right here. So line 117. So it looks for 1 or more repetitions, and it does it greedily, meaning it's going to find as many as it can. It needs at least 1, but it's going to start with the biggest number it can first and work its way down. Just like we had with the curly braces, they're greedy. There we go. So now it's going to go say, all right, there's how many characters can I take? How many possible characters can I get that still fills this pattern before the space? And then how many characters could I possibly get that occur after the space? And it's going to grab as many as it can. So that's the only difference. We added the plus signs. Now if we hover over it, it did. It went and grabbed all the letters it could, and it stopped right there. Why did it stop there? It stopped at the first name because right before the Chad is a comma, and right before the select health is a comma, and the comma does not fit our pattern, so it's excluding it. So when it sees the comma, it's like, all right, I can't include that. So this is as far as I can go when it does these things. Same thing with the trailing the ends, right? There's a comma after Hodge and a comma after health. And so it stops there. So it greedily went and got all the letters it could. And you can see it's not the same, right? Med was only 3, Hodge is 5, health is 6. So it went and grabbed as many as it could. And again, those greedy operators really help us. So it did. We went and we found all the patient names. Well, we got all the names that match. We need to find a way to get rid of these other things, right? Select health, select med. Those things are not patient names. So we are getting them. We just have some false positives we got to get rid of. So we could do it a couple of different ways, right? We could say, all right, what we've matched on is fine. And then we can just go loop through all the results. And as long as it's select med or select health, we're going to skip it, right? So we're saying as long as it's not one of those, we're going to print it, right? So we got Chad, Annika, Matea, and it skipped all the others, right? So it did give us the results because we put a little bit of extra logic in here. And that's a legit solution. There's nothing wrong with it. You would have to keep a track of this, right? You'd have to keep looking at your data. And as you get more and more data, this list is probably going to grow bigger and bigger. You're going to have to write a bunch more exclusions, but it's certainly possible and certainly fine. We can do a little bit better in our case, though, because these are both select med and select health are very similar. We can do what's called an exclude. And I don't think I included this up here because this is one of the deeper downs. Yeah. So I do have a question mark. Don't confuse a question mark with, where were we? Right here. So don't confuse a question mark with a parentheses question mark. Parentheses question mark is very specific and it means don't or not. So we're saying go find, this is all the same pattern we've done before. But then right before it, I said, this is called a look ahead pattern. This thing right here. It's saying look ahead at all those matches and do not include anything that starts with select. So we're saying exclude all the things that start with the word select. That's all we did here. That's all we added here. You can see this pattern starting to get quite unwieldy just by looking at it. We're up to like 30 characters. It's pretty big. But as long as we know how to read it and to break it down, right? We know what that means. We know what that means. At the individual pieces, we can start to break down, and it makes more sense that way. But now if we look at our results, there we go. Now we have just the patient names because we've said exclude everything that has the word select in it. And that worked out for us in this case. It may not work out in all the cases, right? If we had 10 million patients, they're not all going to have the word select. So we are still going to get some false positives, but we can keep fine tuning our pattern, or we can add in some things like this to manually exclude them after we've got our matches, whatever the case may be. But this is pretty good, right? So again, these one lines of code, these little patterns are finding the data for us. Yeah. So again, these are starting to get pretty large and complicated. So what I would recommend, because these can get large and complicated and you haven't used regex before, I assume, it's really helpful to practice regex on your own outside of Python. Because again, it's not Python. Regex is not a Python thing. Every programming language I've ever done has a regex ability in it. And that's for a long time. So I don't know. It's been around for a long time. But I wanted to say that there's some third-party tools that you can use to practice your regex. There's one called Espresso. That's one I've used for a really long time. It's a freeware. You go download it off the internet. I can go show you. I don't have it installed on this one. I have it installed on my my work computer. This is my home computer, so I don't have it. But oh boy, there's going to be a lot of matches for Espresso. Let me try something else. Espresso regex. Yeah, right here. Ultra Pico. So it's a little bit older, but it's a pretty good tool. It comes up with something like this where it has all the options in here and helps you build your strings. So you can start working with them to figure out, you can see it's using the word greedy here. I really like greedy things. It can start helping you build your regular expressions. But not only that, what it does is it breaks it down and shows you what it's doing. That's what I was trying to do earlier. But this does it actually pretty well. It puts it in an order saying, here's what it's doing, here's what that means, and then it puts them all together. And then it has some test data here in the bottom left where your strings, right, here's their regex they wrote up here. It's really big and huge. And then here's the test data down here. You can't really see it. And then it will show you what matches it gets. So you can start playing with it and building up your strings. And then once you have your regular expression string built, you can just copy it out of this Espresso tool and put it in your Python code once you're happy with it. That's one option. The other option, a little bit less intense than that, is you probably don't know this, but a lot of the tools and software that you use today has the ability to use regex in it. Let me go find the year-old one we did. Let's go grab this one. So this is just saying find 1 to 3 numbers. Let me just grab that. Copy. So you probably don't know this, but a lot of your tools that you use let you use patterns. I wrote some of them down here. So VS Code is one. I'll show you that in a second. But you probably don't know this, but Microsoft Word does it too. So again, these are ways you can go practice your regexing. Let me go find Word. All the way to the bottom, apparently. Word. Okay. Come on. Okay, so let's just start a blank document. And then I'm going to put in just some fake data, obviously. Oh. All right, doesn't really matter. So we have some data. Now if we hit Control Find, where is it? Hang on, there's a way to get to, there we go. So when I type in my regex, and rightfully so, it's like, oh geez, I don't see that in here anywhere, right? He's like, I don't see that string over here, right? That's how we've done it before. But if you come over here to this drop down, you can go to the advanced find, and you can say use wildcards. And when you've clicked use wildcards, it's going to treat this as a regular expression. And now if I hit find next, now you can see it highlighted it, what it matched on. It's like, oh, okay, I'm going to treat these like a regex. I found you a double digit, a single digit. These ones aren't greedy in Word because it's doing overlaps. I found a 12. I found the 2. I found the 234. I found the 34 and the 4. I found the 34 and the 4 and the 7. But you can see that, right? How it's starting to do that. We can do the same thing. We can do our lowercase a to z, our uppercase a to z, and then we can just say there needs to be 1 to 4 of them. There we go. So it found Chad. And then the had, and then the add. Because yeah, it's the difference here is when Python does it, it doesn't do overlaps like that, but Word isn't quite on that same par. It's not worried about overlaps. It's just trying to find you as many things as possible. But you can see it's finding us all the strings, upper and lowercase, that are at least 1 character long. We should probably change that to be like, let's just do 3 to 4. A little bit easier. So it's finding those groups of 3, and they are overlapping, but it is finding them. You can see it's following our pattern, and it's working. Okay, so Word does that if you want to practice with that without going to get some extra thing. VS Code also does this. Again, we'll go do a find. So here on the find on VS Code, you have 3 things here. We have the match case. We have match the whole word. And then this very last one, use regular expressions. So you click on that, paste in your pattern. You can see over here it's highlighted all the matches, and you can start scrolling through them. It's like, oh, I found 108 of those bad boys. I don't like this one. It's too many. Let's do what we had before. A to Z. And we need, let's just do 4. Oops, 4 of them. So these are all the 4-letter words. Let's do 8. Oh, geez, there's even more. Let's see if we have any 10-letter words. Yep. How about 11? Yep. Do we have 15? Nope. 14, 13, 12. So 12 letter words is the biggest one we have here. There's just one. But it found it for us. Specifically 12 letters. And we have a whole bunch more 11s, I think. Yeah, so we have 25 11 letter words. We can just start going through them. All right, so you have a chance here in VS Code to use your regex skills or to build them up. And you can see it's going to show you what it's going to match on. And this is doing it greedily. Let me make sure. So if we do 3, let's see if it does overlaps. No, so this is not doing overlapping. So this is what we want, right? This is how Python actually works. Greedily. Okay. So this is a way to practice your regular expressions. And I use a tool called Sublime Text. I really like Sublime Text. It does a lot of great things really quickly. And it also has a way, Control F, right here. So we have case sensitive whole words, just like Word did, but then right here, regular expression. There we go. And so Sublime Text will also do the same thing. So most, I don't know about most, but most of the text editors I use let you use regular expression. And you probably didn't know it, right? If you're not looking for it, or if you don't know what regular expressions are, you wouldn't even know what these were or what they're talking about. But a lot of these tools have them. So you can use them to your advantage. That's what we're talking about here. So figure out just how to do those patterns really well. And then you can just paste them into your Python code. Cool. Okay. So now we've got the patient's ages and we've got the patient's names pretty successfully. Let's try one more. I think this is our last one. Yeah, this is going to be our last pattern. And we got something else to talk about after that. So with our last pattern, we just want to go grab the patient gender, right? We want to go, where's the data again? Right here. So we want to go grab, are they male or female or whatever the case may be. So let's start with a little simple pattern. That's the easiest way to do it. You don't want to start really complicated. You want to start with the simplest thing, see what it does, and then tweak it a little bit. So again, the square braces are just saying go find any of these characters or a range. So we're just saying go find the M or the F. And then the plus just means one or more of those have to exist. So if I hover over it, we got, again, 5 matches, but there's only 3 patients. So it's probably matching things like, let me see. Matea, her first letter is a capital M, or select med, right? So it's probably, those are the other 2 matches. Are they M's? Yeah, they're M's. So that's what's happening, right? So we did pretty good. We got all of our genders, but we got a couple of false positives, right? We got a couple of other things that we shouldn't have grabbed. So let's just be a little bit more specific, saying you have to have a comma on either side, right? You couldn't do it on just one side because like Matei, for example, would match if you just said look for commas on the left. Okay. Select med would be cut out though. So we'd still have one false positive. So instead, what I'm saying is just put a comma on both sides because that's what we see up here, right? With our patient data, there's a comma, a letter, and a comma. And so I'm saying just go find the comma, one or more of those letters, and then the other comma. And then our results are, there we go. We just got 3. It has those commas in there because that's what we told it to do. So we would have to, if we wanted to, we'd have to go strip out the commas in our results a little bit later. And that's fine. But we did get all of our data, right? Pretty easy. And then with that, we can go do a lot of other things. So this is pretty easy. But what if we wanted to go count for other things? I was looking this up. If you're familiar with HL7, either version 2 or the version 3 Fire spec, I put a little link in here. Because when I was doing it, I used to do HL7 V2 stuff. And when I did it, there was 9 administrative genders they're called at the time. So not just 2, not just male, female. There was 9. I was looking at it today to see what this is version 4. Yeah, so it's Fire version 4. So this is different, but they have less now, which surprised me. They have 6 different genders. So we have the male, female, but it could also be an A for ambiguous, O for other, E for unknown, N for not applicable. A lot of those sound like just cop-outs. Because there was 9 when I used to do these sorts of things. I don't know why they got rid of them, but they were like pre-op, post-op, identify as, whatever. There was like hermaphrodites, androgynous, just everything. I don't know why they got the list down, but it's smaller now. So using that sort of spec, we can go find all 6 of those, right? We can just go say, go find those 6. This is obviously not going to match on anything else because our data doesn't have those, but it still matches on the 3 we care about. And it also is letting us look for the other 4 of them that we haven't been accounting for. The other thing we could do, right? So this is the 6. If we thought that the genders might change, like how there used to be 9 of them, we could just say, or just keep our pattern a little more generic. We could just say, all right, just go find a comma, any letter A through Z uppercase, and then the question mark. So I changed it from a plus to a question mark. So if we come up here to see the question mark, right here. So it's changing it from a 0 to a 1, whereas the plus is saying 1 or more. So I'm just saying it's optional. When I change it from a plus, it's saying it has to be there. When I change it to a question mark, I'm saying it's optional. Scroll back down. So I'm saying optionally go find anytime there's a letter in between 2 commas. And again, we still got our same matches. And it'll find anything else that has that same pattern. So it's up to you to decide. We could lock ourselves into the MF. We could go do the standard, or we can be really generic and just sort of hope that this is always going to be a gender. It could be other things in the future, I guess. So you got to be smart to know what your patterns are actually going to match on. And so these cases that I've shown you here are pretty simple, right? Because we don't have a lot of data. What's usually going to happen is you'll get thousands and thousands of rows of data. You'll write your pattern and it's going to be like 95% accurate, but you're still going to get some false positives, or you're going to miss some data because there's really no way to account for everything in all cases unless you like really get into these really crazy regular expressions, which you can do. I just think it's a little bit outside of the scope of what we're trying to do. So I'm just showing you really simple and easy ones. Okay. And so talking about accuracy, so again, I'm just gonna make sure you use those tools, visualize what you're getting to understand it. But we're talking about accuracy on large amounts of data, and even natural language processing. I don't know if you guys have taken the natural language processing class, but regex plays a part in some of that where they're looking for patterns, and then they do further advanced stuff with that. But they do start with some patterns. So these skills would apply to that NLP class if you take it. But we need a way to say, how well are we doing, right? This is a little bit of an aside, but it's worth talking about since we are biomedical informatics majors, and sensitivity and specificity have a pretty big part to play in all the study designs that we do, to know how well we're doing, and then to know if we can improve upon it, right? So if you go read some study like Guilherme or Peter Haug, I'm sure I've read, and Nathan Holst, I've read a lot of their Stefan Maestri. I've read a lot of their papers when I took their courses, and they specify how well is their classification tool doing, right? How well are they doing the NLP things? And they go into like F1 precision and recall and stuff, but those are all based off of sensitivity and specificity. So I thought we could do a really quick example of how well our patterns are actually doing, and then we could quantify it, just so you can sort of tie this all together into the BMI coursework, just to see what it looks like. And so I'm assuming you've all taken the classes on how to do sensitivity and specificity, but if you haven't, I think you can go to Wikipedia or anywhere. There we go. Where is this? This is Wikipedia. That's an easy one. They have a diagram here. It talks about true positives, true negatives, false negatives, and then the calculations you need to do. I actually like this table down here. Or here's some formulas for it, but I actually like this table the best. You take your positive conditions, your negative conditions, and then what it actually was, and then you just sort of fill this in, and then you can see what calculations you can do off that data. So if you're not familiar with that, go read that a little bit first. We're talking about it here a little bit, saying you got to know how many possible matches there were in the text, positive things versus negative things, and then how did your instrument or your tool do? How many did it find correctly versus how many did it find incorrectly? And then here's the formulas, and again, you can just grab those off Wikipedia or your textbooks or whatever. So let's go look at one. Let's go actually figure out the sensitivity and specificity of how well one of our patterns is doing. Okay, so this is the one I pulled this from up above when we were trying to grab the names. This isn't a new one. This is grabbing the names, right? So this is where we had Chad, Annika, and Mateus successfully, but Select Health, Select Med, and Select Health were false. Okay, so this one has some true positives and some false positives. Okay, and so we just write the little table like this if you want. You can do it other ways. I like visualizing it this way. Okay, so we know that there are, out of all these fields, let me go up to the patient data right here. So we know if you separated these all out by commas, like if you did a split on it, there's going to be 18, 6 fields times 3 patients. So there's 18 possible fields here. There we go. So we have 18 possible fields, which is what I'm talking about here. We know 3 of those are names, so 15 of those should be true negatives. 3 of those are names, and then we go find out how did we do. We correctly identified 3 of them, but we also incorrectly identified, and I think it was actually 3. I put 2, but I think it's 3, right? Yeah, we incorrectly found 1, 2, 3, so I should change that math a little bit. So it's even a little bit worse. There we go. That number makes more sense. And so then you just go do this number over the whole number, and then this number over that whole number. Let me go recalculate what that is. Calculator. 15 out of 18, so it's 83. So it even dropped a little bit. So we're sensitive, right? We're sensitive enough to grab all of the right results. We've got all the results we needed, or correctly, all 3 patients. So we're 100% sensitive. But we also brought in stuff we shouldn't have. So we're only 83% specific, right? Our specificity is pretty low. Okay. Well, I guess 80 and above is pretty decent, but we're getting stuff we shouldn't. Okay. So then let's look at how we do that. So with a better pattern, here with the X, now we get all 3 patients and nothing we should. So now we change this, and now we got 100 and 100. And so when you see these numbers, when you go into the other courses and you read NLP or whatever the case may be, they use things like F1, I think is the most common measure. Where's F1? Oh, right here. So they'll use F1 as the number they usually use, which is a little bit different, but it's based off of precision and recall, which is sensitivity is recall, and precision is positive predictive value. So we didn't calculate that, but they're all based off these same things that we've just calculated. So you can go through and figure that out. And once you get to larger corpuses of text, here's the F1 again, then you can start to get more complicated and more accurate numbers than what we're getting, because we just went from, was 183% to 100 and 100. And you're almost never going to have hundreds and hundreds, obviously, because nothing's going to be 100% accurate. But I just wanted to tie this in for you, because we're looking at regex. We're looking at trying to match on strings. I just wanted you to see and know that this is how it's actually done in other segments of our discipline. So hopefully that makes sense. And if you have any questions, just shoot me an email. And the assignment for this week, I haven't put it together quite yet. I went and grabbed the data though. So it's going to be parsing clinical notes. I went and grabbed a bunch of these off of the CDC website. They have a corpus of text you can go grab. And these are from the physical exams. So these are from ED. These are ED notes. And these are when they are admitting the patient. They'll go do a physical exam on them. And so these are all different patients. So I think I have like 15 of these. And these are all from completely different patients. And then the assignment is going to be parsing some data out of these. So that's the idea. I haven't quite got it all organized yet, but it will be soon. So that's going to be the assignment. And again, just shoot me an email if you have any questions. And we are